Hey, so you want to know a little bit about glycolysis. Alright, so first and foremost, glycolysis occurs in a cytoplasm of eukaryotic cells. So we know that with glycolysis, glucose is broken down into two pyruvates. So for every one molecule of glucose, you get two molecules of pyruvate, okay? So you want to keep that in mind. Now, without going into too complex detail, what happens is once you get your two molecules of pyruvate, it enters what's called PDH or pyruvate dehydrogenase complex before going into the citric acid cycle to be broken down into acetyl-CoA before going into the citric acid cycle. But here we're just going to talk about glycolysis, okay? So here what I've done for you, what I will do for you is I'll write out the pathway of glycolysis first, and then I'll draw the structures after. That way I don't take up a bunch of space. So here I've drawn the 6-carbon glucose molecule to your left in red, and I've drawn a couple products for you. So we know that the first reaction is irreversible, and you have an enzyme called hexokinase. So the conversion of glucose to glucose 6-phosphate is done by hexokinase, okay? Now, from glucose 6-phosphate to fructose 6-phosphate, you have a reversible reaction, which is catalyzed by phosphoglucose isomerase, okay? And third, you have fructose 6-phosphate being converted into fructose 1,6-bisphosphate, which is a irreversible reaction, which is catalyzed by phosphofructokinase, okay? So remember that, it's catalyzed by phosphofructokinase. And with glycolysis, you have 3 irreversible reactions, okay? So I will continue with the pathway of glycolysis because this is not it, okay? We have a couple more intermediates to go with, all right? So from fructose 1,6-bisphosphate, you have a reversible reaction catalyzed by aldolase, okay? Catalyzed by aldolase. Aldolase, okay? Now what that does is it creates a molecule called G3P or glyceraldehyde 3-phosphate, okay? I'll abbreviate it here, G3P. Now, G3P can actually be converted into what's called DHAP. The actual name is, it's lost in my memory somewhere, but it is abbreviated DHAP. So, but in order for glycolysis to continue, you have to use the molecule G3P, okay? But I will write DHAP because that's also an intermediate in glycolysis, okay? Alright, so that and the enzyme that catalyzes the reaction from G3P to DHAP is called triose phosphate isomerase. Triose phosphate isomerase. Phosphate isomerase. Alright, so try to keep that in mind. So here's just a quick overview of the pathway. Alright, now I'll keep going. We're almost done. And like I said, in order for glycolysis to continue, you need the molecule G3P. Alright, so I'll continue with that. That being said, so from G3P you have another reversible reaction, which is G3P2,1,3-bisphosphoglycerate. Okay, so you have 1,3-bisphosphoglycerate. Okay, glycerate. Alright, so the molecule or the enzyme that catalyzes that reaction is, you'll remember this one. It's called glyceraldehyde 3-phosphate dehydrogenase, abbreviated G3P dehydrogenase. All right, so I'll write that right here, G3P dehydrogenase. Okay, and I actually want to go back and put in the electron acceptors in this here pathway. Okay, so when you have the conversion of G3P to 1,3-bisphosphoglycerate, you are putting in inorganic phosphate and NAD plus to give you NADH. All right, NADH. All right, and from 1,3-bisphosphoglycerate, from there you have another reversible reaction to give you 3-phosphoglycerate. And you can see we're going from a 6-carbon sugar glucose to a 3-carbon molecule of pyruvate. All right, and you'll see that, and that's how you could really figure out what structures are what, because you know that you're always losing a carbon. Okay, 3-phosphoglycerate. Alright, so the the enzyme that catalyzes that reaction is phosphoglycerate kinase. Alright, phosphoglycerate kinase. Alright, phosphoglycerate kinase. And with that, you have ADP turning into ATP. Alright, so we're almost to our pyruvate. Alright, you have another reaction, and I'll show you the overall pathway once I've completed it. But from 3-phosphoglycerate, you go to 2-phosphoglycerate. 2-phosphoglycerate. Alright, and the enzyme that catalyzes that reaction is phosphoglycerate mutase. Phosphoglycerate mutase. Alright, and to keep moving along, from 2-phosphoglycerate you go to phosphoenol pyruvate. Okay, so from here you go to another reversible reaction. You go to phosphoenol pyruvate. Okay, and what happens is when you convert from 2-phosphoglycerate to phosphoenol pyruvate, you actually lose a water, H2O, or forms of water. And from phosphoenol pyruvate, you finally have your end product of pyruvate. And what I've drawn for you is just, and actually I'll put 2 because you have 2 pyruvates, okay, for every glucose, 1 glucose molecule, and you gain an ATP. And that reaction from phosphoenol pyruvate to pyruvate is catalyzed by pyruvate kinase. Okay, pyruvate kinase. So, and that is just a quick overview of the pathway of glycolysis. And like I said, I'll try to go over the overall pathway for you. Okay, so here you have from pyruvate, and let's go over. Alright, let's go over. Let's see, can we go over? Alright, so from glucose right here, from glucose, you have a enzyme that catalyzes that reaction, which is hexokinase. Okay, hexokinase. As you can see here, hexokinase, and you lose an ATP to form ADP. So from glucose 6-phosphate, you have a enzyme, phosphoglucose isomerase, which catalyzes that reaction to form fructose 6-phosphate. Okay, and again, you also lose an ATP to form ADP. All right, so next, the enzyme that catalyzes fructose 6-phosphate to fructose 1,6-bisphosphate is phosphofructokinase. And as you can see, this is just the overall pathway of glycolysis. Okay, and like I said, I'll draw the structures of each intermediate for you, and you'll notice a pattern. Like I said, you always lose a carbon, all right, to form the final molecule of pyruvate. All right, so again, here's the overall pathway to form 2-pyruvate. All right, 2-pyruvate. Alright, so now I'm going to quickly draw the structures, and like I say, you'll eventually catch on and notice a pattern with that. Alright, so I'm going to draw the structures for you. Alright, so I will draw the structures of each intermediate. So I've already drawn glucose for you on the other page, which is right there, 6-carbon molecule. So now what I'm going to draw for you now is the rest of the intermediates. Okay, the rest of the intermediates. So from glucose to glucose 6-phosphate, catalyzed by hexokinase, irreversible reaction. Here you have glucose 6-phosphate, okay, glucose 6-phosphate, which is still a 6-carbon molecule, okay, still a 6-carbon molecule. You have OH coming down, OH coming up, and HO. So the only difference with this molecule is you have added a phosphate group, and that's given by the name, glucose 6-phosphate. And if you count your carbons, here we will start with carbon number 1 right here. 1, 2, 3, 4, 5. So we know that our phosphate group is going to be on the 6th carbon. Okay, so right here is where our phosphate group is going to go. So I'll draw that CH2OPO3 2 minus. Let's do a better job of that. 2 minus. So that is glucose 6-phosphate. Okay, glucose 6-phosphate. 6-phosphate. Alright, so our next intermediate from glucose 6-phosphate is fructose 6-phosphate. Now, with fructose 6-phosphate, you still have a 6-carbon molecule. However, it's not a cyclic, well, it's a cyclic structure, but it's not this here cyclic structure that we have here. Okay, I'll show you what it looks like. So you have fructose 6-phosphate. So here's fructose 6-phosphate, and there we go. So we have our CH2OH, OH, and OH coming up, and a OH going down, and again you have a phosphate group still there, CH2OPO3 2-. Sorry for the clutter. But here again, fructose 6-phosphate, still on that 6 carbon, okay, if you count them. Oops, let me get a better color so you can follow the carbon. So 1, 2, 3, 4, 5, 6. Alright. And that's the easy way to follow the carbons throughout glycolysis, is number them, okay? Number them. So again, that was fructose 6-phosphate. 6-phosphate. Alright. So now from fructose 6-phosphate, you go to fructose 1,6-bisphosphate. Okay, again, fructose 1,6-bisphosphate. So I'll draw that over here so you can see the difference. Okay, so now we have fructose 1,6-bisphosphate. So you'll have a phosphate group at the 1 carbon and a phosphate group at the 6 carbon. So here we go. And we have OH, OH, OH. And here, like at the 1 carbon, like I said before, CH2OPO3 2-. And here again, we still have our CH2OPO3 2-. Alright, and that again is fructose 1,6-bisphosphate. Fructose 1,6-bisphosphate. Phosphate. Alright, and again, numbering our carbons, we could still count the carbons and locate our number 1 carbon. So this is 1, this is 2, 3, 4, 5, 6. Alright, so now we move on from fructose 1,6-bisphosphate to G3P, or glyceraldehyde 3-phosphate, and this is where the ring actually opens up, or the cyclic structure turns into a linear structure. Alright, so here I am going to draw for you. Let's see, I'll draw it under. Here I'm going to draw for you another intermediate, which is G3P. Alright, so here's the H, and I won't put in the carbons. Like I said before, I know that many people, you have to have organic chemistry before biochem, so I will hope that you know where the carbons are. If not, you could request an additional video and I could explain where the carbons are. Okay, so here is G3P, or glyceraldehyde 3-phosphate, okay? 2OPO3 2-. And that is my abbreviation, G3P. Alright, so we're almost there. So after G3P, we have also DHAP. Oops, I'll actually draw the structure for you instead of just write it. But we have DHAP. And this is an easy structure that you can remember, because you just have this and you have CH2OH and OH. 2 minus POH2C. Oops, I did that wrong. It's supposed to be CH2. 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 Alright. And that is DHAP. Okay. So again, here are the structures. They go in order. So you have your glucose molecule, which I've drawn for you over here, which goes to glucose 6-phosphate. From glucose 6-phosphate, you go to fructose 6-phosphate. From fructose 6-phosphate, you go to fructose 1,6-bisphosphate. From there, you go to G3P, and you actually could go from G3P to DHAP, but to continue glycolysis, you need G3P. All right. So from G3P, you have 1,3-bisphosphoglycerate. 1,3-bisphosphoglycerate. All right. So I'll draw that for you. I'll draw that for you. So from, again, G3P, which you see in the orange up there, I'll draw for you 1,3-bisphosphoglycerate. All right. So here we have a phosphate group, and we have OH and a H, O and CH2OPO3 2 minus. So if you look at G3P and 1,3-bisphosphoglycerate, what do you notice there? Well, you notice that that hydrogen here is now a phosphate group, okay? And this is the creation of pyruvate. This is what happens, okay? So 1,3-bisphosphoglycerate. All right. Now, from 1,3-bisphosphoglycerate, what do we go to? We go to 3-phosphoglycerate, okay? 3-phosphoglycerate. And I'll draw that for you down here. So we have O minus. And that negative charge can actually go from this oxygen right here back to this one. So, but I'll just draw it like that. So we have OH, H, and CH2OPO3 2 minus. So here you've lost a phosphate group, okay? Still the same number of carbons. We haven't reduced anything yet. But this is, so you have 3 carbons here. And this is how many carbons are in pyruvate. So you won't be losing any more carbons, but you will definitely be changing oxidation states. Alright, so that is 3-phosphoglycerate. Alright, now from 3-phosphoglycerate we go to 2-phosphoglycerate. Now what does that mean? That means that we have our phosphate group here at the number 2 carbon, which will be right there. All right, so I'll draw that structure for you. We have 2-phosphoglycerate, O minus, O, OPO3 2 minus. Our H is still there, and our CH2OH this time. We have CH2OH. And what happened is, and I'll show you just quickly, what happened is this here phosphate group actually moved up, and now you have a CH2OH there. Okay, and again, you could look at the overall reaction pathway and create a sheet with the reaction pathway as well as these structures, okay? And then it'll really make sense. So here you have 2-phosphoglycerate, 2-phosphoglycerate. Alright, and 2 more structures to go. So from 2-phosphoglycerate, we go to phosphoenol pyruvate. Phosphoenol pyruvate. OPO32 minus H. And here we have, oh, I drew that wrong. Let's back up. So we actually have, this is phosphoenol pyruvate. We still have our O minus there, O minus, but we have, it looks something like this, a enol, okay? So I'll actually draw in the carbon here. You still have a carbon right there, but I'll draw the carbon here so you can see the enol, okay? PO3, 2 minus, and that is, and this structure here is phosphoenol pyruvate. Phosphoenol pyruvate. And finally, last but not least, the structure that we've all been waiting for, pyruvate. Alright, pyruvate. And this is pyruvate. The structure that we've all been waiting for, pyruvate. Pyruvate. Alright, and that is the structure of pyruvate. And again, these are all the structures, intermediate structures of glycolysis. So let's see if I can just run through these real quick. So you have glucose to glucose 6-phosphate. From glucose, I'll draw arrows for you. So from glucose 6-phosphate, you go to fructose. From fructose 6-phosphate, you go to fructose 1,6-bisphosphate. From fructose 1,6-bisphosphate, you go to G3P. And I'll actually draw the reversible reaction. So this is reversible. Nope, it's not reversible. That's phosphofructokinase. So let me actually erase that. This is reversible. There we go. Okay, fructose 1,6-bisphosphate to G3P is reversible, and G3P to DHAP is also reversible. And again, from G3P, you go to 1,3-bisphosphoglycerate, which I actually drew all the way over here. Alright, so from there, from 1,3-bisphosphoglycerate, you go to 3-phosphoglycerate, which I've drawn for you right there. And from 3-phosphoglycerate, you go to 2-phosphoglycerate. From 2-phosphoglycerate, you go to phosphoenol pyruvate. And finally, from phosphoenol pyruvate, we go to pyruvate. So that is the overall pathway with the structures in glycolysis. Okay, so hopefully you could figure that out and kind of go along with me there. If you need any more understanding or knowledge of glycolysis, I can also do more videos on how you have negative feedback with phosphofructokinase, so on and so forth. Okay, but again, this is just a quick overview, as quick as I could without going too fast, of glycolysis. Remember, glycolysis occurs in the cytoplasm. Okay, remember, it occurs in the cytoplasm. And you make 2 molecules of pyruvate. pyruvate. And if you want the net reaction, I can also write that for you real quick. The net reaction, really quick, the net reaction, you have glucose plus 2PI plus 2 ADP plus 2 NAD plus, which gives you 2 pyruvate plus 2 ATP plus 2 NADH plus 2H plus 2 H2O. And that there for you is glycolysis. Alright? Glycolysis. So again, comment on a video if you liked it or not. If not, I can always improve. But here is glycolysis for you.